Hello, welcome to College Algebra. Today we're going to talk about section 4.2, that is the exponential function. We learned about many functions before. We learned about the linear function, constant function, quadratic function, rational functions. Today we're going to learn about exponential function. It's a new kind of function for you. So let's define what is an exponential function. So if we talk about b, we let b be a constant real number such that b is a positive number greater than 0 and b cannot be 1. Then for any real number x, the function, the exponential function f of x is b to the x. b is positive and not 1. X is any real number. We call this exponential function. Alright, so again, the two conditions that must be in that form, b to the x, b is positive and not 1. So let's double check with these functions. F of x equals 7 to x. So here's b is 7, which is greater than 0 and not 1. And x is an exponent, therefore this is an exponential function. Let's check this one. Here, negative 3 to x, so b is negative 3. Is negative 3 positive number? No, so this is not an exponential function. F of x is the square root of 2 of x, so b is the square root of 2. Let's double check. Is the square root of 2 greater than 0? Yes. Is the square root of 2 1? No. So therefore, this is a real exponential function. Alright, how about this? F of x is x to the 7th. So what is b here? Is b x? No, this is not a form of b of x. So this is x to the 7th. So this is not exponential function. 1 to the x. Here's b is 1. So b is a positive, yes, but b cannot be 1. Therefore, this cannot be exponential function. Okay, so far? So now, we are going to graph an exponential function where b is 2. So let's double check that. So first of all, we have to fill that table. So in order to fill that table, I would start by 0 because this is the easier way. So 2 to 0, anything to 0 is 1. So this is 1 because 2 of 0 is 1. Okay, let's go for the positive part first. So what is 2 to 1? What is 2 to 1? Is 2. So therefore, here is 2. What is 2 to 2? It's 2 squared is 4. So here is 4. What is 2 cubed? So 2 cubed, 2 times 2 times 2 is 8. So therefore, it's 8. Now let's go to the negative one. So the negative one, when I have here 2 to negative 1, this is the exponential of a negative 1. We flip the number over, so that would be 1/2. So if you look at 2 to 1 is 2, 2 to negative 1 is 1/2. So I have 1/2 here. Similarly, here I have 2 to negative 2. I can rewrite this as 2 to negative 1 squared, and I have 2 to negative 1 is 1/2. So 1/2 squared is 1/4. I'm going to erase that, so I have a room for graphing the function. Okay, I hope that everything is clear so far. Okay, so let's graph this. Here is, let's make that, so we have 0, we have negative 1, negative 2, negative 3, and I have 1, I don't have -3, that's fine, 2, and 3. And I have here, let's say this is 1/2, I have to 8, well, let's make this 1, this is 1/2, and this is 1/4. This is 1, 2, 3, 4, 5, 6, 7, and 8. So it's 1, 2, 3, 4, and here is 8. Okay? So let's get the first point, and I start with 0 and 1. So I have 0 and 1. Okay? I'm going to write this point here, 0 and 1. Okay? And then I have 1 and 2. So 1 and 2, 2 and 4, and 3 and 8. Okay? -1 and 1/2, and -2 and 1/4. So if I graph this function, it never touched the x-axis. So if we graph this, that would be this way. Okay, this is f of x equal to the x. Okay, notice 3 things about the function. The function passes through 0 and 1, and this is 1 and 2, which is 1 and 2. And what is 2? 2 is the value of b. So I'm going to mark these 2 points, and then we find these properties of the exponential functions. First of all, the domain, the x-axis, goes from -infinity to infinity. The range, the exponential functions cannot go below 0, and also cannot touch the 0. So we see that 0 is open set, and to infinity. The horizontal asymptote for this function, you see the horizontal asymptote, when the function goes to -infinity, here, okay, the function goes to the horizontal asymptote, and this one here, I'm sorry, when x goes to infinity, the function goes close to 0. So this is the horizontal asymptote when explains the end behaviors. Okay, so here's my horizontal asymptote is always y equals 0, unless the function is shifted up or down, and we have a different idea about that. Okay, so the horizontal asymptote is y equals 0. Okay, for every exponential function, the graph passes through 0 and 1, and 1 and b. So here is 1, and 2 is b, because 2 is b here. If b is greater than 1, as here, the function is increasing, and we see this the function increasing, and we call this exponential growth. That it goes increasing, and we call this growth. So what if b is between 0 and 1, which is fraction, 1/2, 1/3, 1/4, then f is decreasing, and exponential, we call it exponential decay. That something is decomposed or decay. Okay, so let's talk about graphing some functions. Before I graph the function, I want to show how we graph these two. So let's see. So we agree that any exponential function passes through 0 and 1 and b, and 1 and b. So here's 1 and b. Okay? So for this one, b is greater than 1, and we call this function increasing. And it's a exponential growth. If I have b is between 0 and 1, again, the function passes through 0 and 1, and also 1 and b, so here is 1, but b is less than 1, b is between 0 and 1, so it goes, here's b, it goes this way. And again, this point is 1 and b. So this is increasing, the first one, and this is decreasing. Okay, I hope this is clear so far. And for both of them, the domain is negative infinity and infinity, and the range is from 0 open. You cannot touch 0 to infinity. I hope that this is clear so far. We're going to graph 4 more functions, and we see how it goes. All right, so the first function we are going to graph is 3 to the x. F of x equal 3 to the x. So what is the value of b here? The value of b here, b is 3. So I'm going to go for the graph that way, and I know that any exponential function must pass through 0 and 1. And I have b is 3, so again that must go with 1, 1, and 3. So when here's 1, 2, 3. So here is 3, this is 1, there is 1, and 3, and the exponential function must go this way. So again, any exponential function, we define b first, and then I define the 2 points, 0 and 1, and 1 and b, and here's b is 3. And I connect them in the form of the function. Why is that? Because b here is greater than 1. Okay, let's get another example. I have f of x is 1/3 to the x. So now b equals 1/3, which is b is 1/3, where 1/3 is greater than 0 and less than 1. So how can I graph this function? So I'm going to define the 2 points again, 0 and 1, and 1 and b. So here's 0 and 1, 0 and 1. And 1/3, 1 and b, so I have 1, here is 1, and b is 1/3, so this is 1/3. So here is 1 and 1/3. And then that must be, because it goes decreasing, so it goes this way. Okay? So again, 0 and 1, it passes through points. 0 and 1 and 1 and 1/3. So I'm going to call this 1 and 1/3. Okay, maybe. Okay? Again, the horizontal asymptote is y equal 0. Okay? Let's get another example with transformation here. So you want to graph the function f of x equal 4 2x minus 3. So here is find 4 to x, and then negative 3 minus 3, I am going to vertically shift the function by 3 units, down by 3 units. So I'm going to start with original function for 2x. So I have b is 4. This is greater than 1, so the function looks like this way. So it passes through 0 and 1, and 1 and 4. So I have 0 and 1 here, and then 1 and 4, 2, 3, 4. I'm going to graph the original function here, and this is 1 and 4. So it's the original function. Now I'm going to shift this down by negative 3. So the easiest way to do that is to think about this as y equals 0. So we have to shift it negative 3, so this is negative 1, negative 2, negative 3, okay, and make this line, and follow the same thing here, so that 0 and 1, we're going to decrease this by 3, so there's going to be 0 and negative 2, or we can count down 1, 2, 3, and this negative 1, this negative 2. So that must be this, the new point is a 0 and negative 2. And for that one also, we're going to go subtract 3, so that would be 1 and 1. So here is 1 and 1. So here is 1 and 1. So the new function would be that way. So this is my transformed function, which is 4x minus 3. Watch something here. The horizontal asymptote is different. So now, when the function, the end behavior of the function is close to, not to y equals 0, but y equals negative 3, because I shifted the function down by negative 3. Okay, let's get another example of transformation. I have f of x equals negative 1/3 to x plus 1. So again, what is b? Is 1/3, not negative 1/3, 1/3, which is between, 1/3 is between 0 and 1. So the function would be this way. Okay, so the first thing is to graph the original function. I have one transformation, here's two transformation, so we're going to work on them one by one. Okay, so the first point is 0 and 1. Here is 0 and 1. We define the 2 points. The second point is 1 and b, so here is 1, and b is 1/3, and go with 1/3 here, so this is b. So this is my original function, whereas here is 1 and 1/3. I think it's in your notes is 1/2, but it is okay. I'm gonna go with 1/3. Okay, the second thing is to shift the inner, here's the inner one, x plus 1. So what do you think? When here we shift it down, we shift the function down by 3 points. But here, this is in a domain, so I shift it horizontally by 1 point. To the right or to the left? To the left. So here, I am going to do this. I'm going to shift this point down. So instead of 0 and 1, this is going to be negative 1 and 1. So I have to have here negative 1 and 1. So here is negative 1 and 1. And this one I'm going to shift it this way by 1, so I'm going to get 0 and 1/3. So this is 0 and 1/3. And then I'm going to graph my function, so that is 1/3 to x plus 1. Now the last thing is to reflect the function about x-axis or y-axis? X-axis. So instead of getting -1 and 1, I'm going to reflect it. So the 1 would be negative and the 1/3 would be -1/3. So now I'm going to go to the point here, -1 and 1. So here's -1 and 1. Okay? And here is 0 and -1/3. So here is 0. Here's this one is -1 and -1. And here is 0 and -1/3. And then I go graph the function, which is reflected this -1/3 to x plus 1, which is reflected about x-axis. Okay, last thing I have to do for today before we get the application in the next video is, what if there is a special number? We have to learn about that, is e. So base e, so we learned about the base b, so one of the b values is e. The value of e is 2.71828845, and it's very long decimals. I'm going to stop by this one, but you're going to find a lot of numbers. The more decimals we have, the more accurate. This number is an irrational number, so it has no end here. You can't represent this number as a fraction, p over q. Okay, the scientist or the mathematician who discovered this number, his name is Euler. And we call this base e, we call e the natural base. Okay, and we graph the function f of x equals, instead of b, we call it e to the x. So now again, it's similar to any function we learned. It passed through 0 and 1. But here it's going to be 1 and b, but my 1 here, my b is e, which is 2.7. So that must be 2.7. And again, it goes this way. Well, I hope that this is useful for right now. In the next video, we're going to discuss the applications about exponential function. Thank you, and see you in the next video.